let's talk about the Pythagorean Theorem. The Pythagorean Theorem is powerful and it's going to follow you through your math life. So let's learn it and let's apply it. So we're talking about a right triangle. What is a right triangle? Well, this is one where we have one angle measuring 90 degrees. And you'll know where the 90-degree angle is. I'm going to square it for you right here on the triangle. It's going to be where when these two lines meet, they form a 90-degree angle. So you have a 90-degree angle formed with side A and B because those two lines are perpendicular to one another. So we're going to denote perpendicular like this. This means perpendicular. And that tells us when two lines are perpendicular, they create a 90-degree angle between them. So in our right triangle, we have one angle measure as 90 degrees, but these other two angles here are not necessarily 90. Okay, well, they're not because 90 and 90 would add up to 180, and we know a triangle's angles all add up to 180. So we need these other two to divide that other 90 degrees. So the Pythagorean theorem tells us this. Now that we know what a right triangle is, the Pythagorean theorem goes on to say that if you have a right triangle, then the side lengths of the legs A, B, and C are given. And it will always be the case in a right triangle that A squared plus B squared will equal C squared. Now, it's important that we know who C is. C is always referred to as the hypotenuse. And the hypotenuse will always be the side that is opposite of the 90-degree angle. So notice that straight across from my 90 degrees is my side length C. And C, the hypotenuse, is the longest side. It makes sense that the longest side corresponds to the side opposite of the biggest degree, the 90. So why do we need the Pythagorean theorem and how will we use it? Well, it's used a lot in trig and it's used a lot in calculus. It's just used a lot in math, period. But let's try to work through an example that uses the Pythagorean theorem. So we've got determine if a triangle with legs A equals 1, B equals 2, and C equals root 5 is right. So we need to go and see if this triangle with these legs is in fact a right triangle. So what I'm going to do is I'm going to go ahead and draw, assuming it's right, and see if we find this to be incorrect. So I know I can make side length A 1, and I'll make this B equals 2. And it didn't necessarily matter who was A or B, I just arbitrarily picked. And we know that we'll have a right angle here, and opposite my right angle would be C, which is root 5. Now I'm drawing the picture as if it is right, not knowing quite yet if it is. I'm just trying to display what I'm working to try to solve. So if this is right, so if my triangle is right, then the Pythagorean theorem would apply. So I'm going to put then Pythagorean applies. So if a Pythagorean applies, let's try it. That means that A squared plus B squared must equal C squared. So that would mean 1 squared plus 2 squared must equal the square root of 5 squared. Now notice I put parentheses around the square root of 5 because I want to make sure we know it's root 5 times root 5. So let's solve this. The square root, 1 squared is 1. 2 squared is 4. Equal to What is the square root of 5 times the square root of 5? Well, remember, if we take the square root of anything and we multiply it by the square root of itself, we get back just that number. Let's see why. In other words, I'm going to prove to you why this will just result in 5. Well, that's because we've got 1 plus 4 on this side. I'm just going to leave it alone for now. I'm going to rewrite the square root of 5 times the square root of 5 as the square root of 5 times 5, which equals the square root of 25, which equals 5. So it is always the case that when you take the square root of a number squared, that's what this is here. This is really just the square root of 5 squared, and I don't need these parentheses, you get back itself. So anytime you take the square root of a number squared, you just get the number. And I proved that here. So now, back to Pythagorean Theorem. Did 1 plus 4 equal the square root of 5 squared? Well, yes, because 1 plus 4 is 5, and on the right-hand side, we got 5. So this triangle is right. We are working with a right triangle, and Pythagorean theorem showed us.